All right, in this video we're going to be talking about some more details of method calling and constructor invocation. And we're going to take a look first at what is it that goes between these parentheses that we're seeing when we declare methods and when we call them, and when we declare constructors and we use them. And also, what is it that's going on with this return statement? We need to learn some more details about it. Before we begin, I've got this pair of files that I'd like you to read through and think through for just a moment and try to answer the question, how many times is the user prompted for a double value when this program runs? So go ahead and pause the video and we'll come back in just a moment. All right, so we know that every Java program begins in the main method. We're going to start right here at this line. Console class, console variable is assigned a new console object. We know now, having seen a little bit about object-oriented programming, that this is actually going and calling the constructor of the console class. We're not going to worry about that. We're going to assume that it just does its thing, and we've been using that all semester, so we don't have to worry about it too much. The next line, we see that we're declaring a variable named a. So I'm going to set up a little label here for a and just make a note that it is a point. And we are assigning to it whatever the result of calling this new point constructor is. So we know that this is a constructor call because we see the keyword new followed by a class name and some parentheses. So what happens is we drop a little bookmark. We say we're going to come right back here, and our code jumps to the point class constructor. And remember, the constructor we can identify by the keyword public, no return type, and then the name of this sort of method, this special method that's a constructor, is the same as the name of the class it's declared in. We see that we're actually making a new console within the point constructor, and here we're prompting the user for a double value. So that's the first time that we are prompting the user for a double. I'm going to just make a note of that. We've prompted once, and we're prompting the user for x. And so what we're doing now is we're setting up an object. So I'm going to set up a little object here with a field x, and let's say that we gave 1.0 as the x value. After we're done with that line, we continue on. We see that we are prompting the user again for a double value. We're waiting for them to type in a value for y. As soon as they do, we assign y field whatever value they gave us. So let's say y is 2.0. And then we're done with that line. And so now we have these two fields populated or initialized in our constructor, and that's what the purpose of a constructor is. The purpose is to initialize the fields of an object. Finally, we reach the close, the console closes, and we return back to where we came from. In this last step, what happens here, which we'll talk about again, is we no longer, we've evaluated this new point to be this actual object, right? So this idea of, hey, we're going to go set up a new point, what's now become or evaluated to this particular object in memory. So we would say that A now points to this particular object, right? And it's a point type, point being like a Cartesian access point or Cartesian coordinates point. All right, so we're done with that line, and now we see that we're initializing another point named B to be a new point object. So what do? We drop our bookmark. Actually, let me set up my variable reference here. B is a point, and we drop our bookmark. We come over, we create a console. We ask the user, hey, what is the x value? So now we're setting up another object here, which will be b, and its x value is going to be, let's say, negative 1.0. And its y value is, and we've just prompted the user for x. Let's prompt the user for y, so that's the fourth time the user is being prompted. Y is negative 2.0, let's say. And we reach the console close. We finally reach the end of this constructor call. We go back to where we came from, and now B is going to point to that particular object right there. Then we print done, and this program is complete. This is a silly program. We didn't do anything with these points. All we did was print the word done. In the process of setting up those 2 points, so we prompted the user 4 times. And the purpose of this little exercise was to point out that even though this particular piece of code is only written once on our in the point.java class, it's getting made use of twice, and it has different results based on the data that the user gave us. And what that led to was 2 very different objects existing in memory. And so the objects A and B, they're both of type point. They both have the fields X and Y. However, the values for those fields X and Y, A is a point at 1, 2.0. So 1, 2.0, say somewhere right here. This is where A would be if we visualized it. And B is a point at -1, -2.0, which would be down here. So we've got two objects in memory that we could then go off and do further work with, and we'll be looking at how we might do that today, that we've constructed. So the three things classes are made of are fields, and these define what the objects can store, just like that point stored X and Y. And all objects of the same type have the same field. So every point has an X and a Y field. But the values that are plugged into those fields can be distinct and different. Classes have constructors, and these are responsible for initializing an object's fields. Constructors have the same name as the class they're declared in, and these are called when the new keyword is encountered. So when we saw a new point, a constructor was called for the point class, and this sets up that new object. Finally, methods specify the commands we can send to an object via method calls. So we'll see that the point class is going to have a method like a.getX. And if we called, the a.getX method, it would return to us its X value. These methods, like getX, we'll see, they can access an object's fields, and they can return values back to the user. So this is how we can ask a particular point, hey, what's your X value? What's your Y value? What quadrant are you in of quadrant 1, 2, 3, 4, so on and so forth. So today we're going to look at much more depth on the method call move. How do we declare a method that needs extra information? How do we call such a method that needs such an extra information? Similarly, how can we write a constructor that does something like new point 1.0, 2.0? How do we declare a constructor that we can give it the values we want for X and Y so that it doesn't have to prompt the user every time? And then we're going to look at what are the rules of the return statement. And these are three really important questions that if you have a full understanding of, you'll be in great shape for working with methods. In today's hands-on materials, we're going to be using Cartesian coordinate ideas, or points and paths, as sort of the basis with what our code is going to model. So point is an object that has an X and a Y property or field. And the path is simply a series of point objects, right? And so a path is going to have a field named points, and its type is going to be an array of points because we want a path to be made up of many, right? And so it's going to have a field that looks like this, an array of points. And we'll build some functionality around paths as well. So the point class has an X and a Y value. It also has some capabilities, some things that we can ask it. So these are methods, and we'll see them defined in just a second. We can ask a point, hey, what's your X coordinate value? What's your Y coordinate value? What quadrant are you in? If you remember the quadrant system, one of the 4 quadrants, or we're going to say 0 is anything on an axis. So we're going to start off with a hands-on, and what I'll have you do is open up the files point.tests.java and point.java and try and get them open side by side. If you don't remember how that works, essentially you just have both files open and you drag one file over to the side. I like to have the class that I'm working on, so in this case point, on the right hand side, and the class with the main method on the left hand side for tracing purposes. From here, go ahead and pause the video and read through each file. See if you can predict what will happen when you run the main method. Go ahead and try running the main method, and your goal for this hands-on is to try and get point A in quadrant 1 and point B in quadrant 3. So spend a few minutes playing around with values for coordinates in A and B, and then check in. Actually, don't check in, this is just a video. Just resume the video when you're done. All right, so let's try this out. So I'm going to go ahead and run this program. And so notice it's asking me first for an x variable. This is the field of our first point, and I'll give it 1.0 and y of 1.0. And now we're being asked for the field of our second point. I'll say negative 1.0 and negative 1.0. And we see that A is in quadrant 1, B is in quadrant 3. Well, what just happened here? So kind of like we talked through in the opening question, we see that 2 points are being created. First, A is being constructed. When this constructor call is happening, it jumps us into the constructor. The constructor is asking us for an x and y, and it comes back. And now A is an object that has whatever values we typed into x and y stored in its fields for x and y. The same thing happens with B, right? We come to the constructor, we come back. And so now B is initialized to whatever we typed in that second series of x and y fields. And then we see we're going through and we're calling a few methods here. So first we're saying print out A colon space and then whatever the result of toString is. So toString is a method that is declared in the point class. So that means when this particular line runs, what's going to happen is we're going to place a little bookmark here. We're going to jump to the toString method. We're doing this within the A object. So whatever fields we typed into x and y for A, that's what's going to be replaced by x and y when we use them in this expression. And so this is going to return to us, I typed in 1.0, 1.0. This string would evaluate to this had I typed 1.0, 1.0 into the console, and this is what's going to be returned. So this is going to return up to here. This method call gets replaced with that string 1.0, 1.0, and then A colon would be concatenated to that and it would get printed out, right? So that's how the method call works. We then reach a call to the getQuadrant method. And here we're asking A, what is your quadrant, right? And so we can step through that very quickly. And remember, let's say that I typed in x of 1.0 and y of 1.0 as well. So here, the getQuadrant call is right here. I jump up to the top of this method. Is x greater than 0? Yes, it's 1.0. And is y greater than 1.0? Yes, it is 1.0 as well. So we reach a return statement. And as soon as we reach that return statement, we go back to where we came from and replace that with 1. So this is what's going to cause a.getQuadrant to be printed with 1 concatenated to the end of it. We'll talk through these other methods like maximum as we move further into today's materials. But if you want to spend a moment to trace through what's happening for each of these and to consider what happens when you call getQuadrant in order for it to return 3, like it did with B, I would recommend spending a moment reading through that. So wouldn't it be nice if we could construct a point object without having to be prompted for x and y, right? It's kind of annoying and frustrating that each time we want to test this out, we have to type in a new x and a new y. What if we always wanted to test out a point at 1, 1 or a point at -1, -1? So we need a way to give the point constructor an extra piece or two of information. We need to be able to say, hey, point class, construct a new object with coordinates 1.0, 2.0. Or 1.0 for the x coordinate and 2.0 for the y coordinate. In code, what we want to be able to say is something like this, right? Declare an object A of type point and assign it a new object of type point that has an x value of 1.0 and y value of 2.0. In order to do this, we need to learn something called parameters. So parameters are what allow us to make this happen. And so what a parameter does is it gives us the ability to say, hey, in order to use me, you're going to need to give me some more information. And the way that we specify this in the abstract is between those two parentheses that we've left empty so far. So here's our constructor declaration. Our parameter list is going to go between the two parentheses when we declare our constructor. And so for point, when we declare our constructor to have 2 parameters, one for x and one for y, it's going to look something like this: double x, comma, double y. And boy, don't these look like variable declarations? Sure enough, they actually are variable declarations, and we'll see why they are in a second. They're just special variables called parameters. These variables are assigned when a constructor or a method is called. And so when you have more than one parameter that you're specifying as part of a constructor or a method, you separate each one with commas. If you had only one, like let's say we had only double x, you would not need a comma or anything like that. We would just say double x. And then of course, like we've seen so far, if you have no parameters at all, you just use empty parentheses. You always have to have the parentheses there even though you aren't declaring anything. This is just part of the Java language. So what impact does declaring parameters actually have? So here, let's say we add a constructor that looks like this, that says point class has two parameters, a value for x that's double and a value for y. And so what this is saying is in order to call this constructor, you have to give me two double values. I don't care what those double values are, but they have to be double values and you have to give me two of them. And so if we actually wanted to use this constructor in our code from, say, the main method, we would be able to do it like this. We would say point A is assigned a new point, and we're calling the constructor that has two parameters, and they both have to be double parameters. And so here, this 1.0 is corresponding to the x parameter, and this 2.0 is corresponding to the y parameter. We'll get a shot at, we'll get to try implementing this on the next slide, right? So in this hands-on, what I'd like you to do is pause the video and add an additional constructor to the point class with the parameters below. And then try changing the constructor calls from within the main method to make use of this new constructor. Run through the program and convince yourself you understand how it works. And I'll come back in just a minute. All right, so I'm going to add this constructor to my code. So here is our first constructor, and notice this one has no parameters. We can add another constructor, and it will be a constructor that has two parameters, double x parameter and a double y parameter. And what we're going to do is we're going to say the x field is assigned the value of the x parameter, and the y field is assigned the value of the y parameter. And that seems kind of funky, but we'll talk through what's going on here and why we do this in just a second. But remember, when we store a value in a field, it means that object is memorizing that value, or it's keeping track of that value. So in order to call this over here, now we have to say 1.0 comma 2.0. All right. And so this method, this constructor call is now using this constructor. This constructor call is still using the original constructor. Notice that if I had a single double value in here, we would get an error, and it would tell us the constructor for the point class that takes only one double parameter is undefined. As soon as I add another parameter, we're okay, because notice the number and the type match up with this particular constructor down here. If I tried to make this a string like hi, we would see that Java would tell us again that the constructor double for point that takes a double and a string is undefined. If I tried to give it 3 values here, it would tell us again that this constructor is undefined. So in order to call a constructor with these types of values, to give it more information, a constructor that takes those parameters has to be declared. All right, so let me make this negative 1.0 and negative 1.0. All right, so I can run this program, and notice that now I'm not prompted for anything. The program just runs straight away, because what happened here, and we'll talk through this in depth on the next slides, is Actually, I might leave it for the slides to talk through, but the gist is when we reach this construction call, we jump over here, but now x, this parameter, is assigned 1.0, and this y parameter is assigned 2.0. We then take those and store them in our fields, and we've constructed a new object in a much simpler way than having to prompt the user each time for those values. So let's actually slow down and talk through that step by step. Before we do, I want to just put one other piece of terminology out there because you're going to hear me say this in these next few slides. So an argument is the extra piece of information that we're passing to a constructor or a method that declares parameters. All right. So this can be somewhat confusing syntax terminology, but the point here is when we are declaring that we need extra pieces of information, these are called parameters. We don't yet know what those values are going to be. We're saying, hey, as a constructor or as a method, I need you to give me these things in order for me to do my job. Hey, as a constructor of the point class, I need you to give me 2 double values in order for me to store my job. And then over here, when we actually make use of that and say, here are the values that we want you to use, 1.0 and 2.0, those are called arguments, right? And so we'll see that arguments are passed to parameters in the next few slides. The type and the number of these matter, and the order matters as well. Notice that if we flipped around 1.0 and 2.0, it would have a very different meaning. The same is true with method calls. So we've been looking at a constructor example, but remember a constructor is just a special method. So more generally, this works with methods. A class that you haven't seen the code for yet is console, and console has a method named promptInt, and what do you know? It takes a string prompt, and if you give it a string, it's going to print out a specific string asking the user, hey, to give you something specifically. So in the last lecture's slides, we saw that we asked the user for their age by calling the promptInt method of console, and we gave a single string argument. So let's take a look at how this works as programs run. So starting from this side of the slide where we're in pointTest.java, what we're saying here is we're declaring a variable a and assigning it the result of calling a constructor of point with values 1.0 and 2.0. So when we reach a constructor call or a method call, the first thing we do is we drop a bookmark and we say, we're going to come back here. All right, this is hold your horses. We're going to be back here. Don't worry. We're definitely coming back right to this point, but we're about to go somewhere else for a little bit. Next, what Java does is it finds the class. In this case, point is our class, and it looks to make sure there's a matching declaration with the same number, so 1, 2, and type, both doubles, of parameters as we are giving arguments. So these are our arguments, and we have to go find in the point class, is there a constructor that has 2 parameters and both of them are type double? Sure enough, there it is. Right? So you'll get an error if you try and call a constructor or a method and there's a mismatch between the arguments that you're providing and the parameters that it can accept. And so there's this one-to-one correspondence between arguments and parameters. So what happens next? We now know that we have a matching constructor. We found it. We know that we can call this. So what we're going to do is we're going to jump into the point class. And this is where something kind of magical happens. All right. So you'll never see this step here. The step that I'm drawing a box around. This is a step that you can't see when you're writing the code. But what happens when Java reaches this point, right before it jumps into the constructor, what it does is it says, this first argument here, we are going to assign that to the x parameter. The second argument here, we are going to assign that to the y parameter, to the second parameter. And so these are the steps that it's going to take before it begins running the constructor, right? And so this is what we call parameter passing. We're passing these values, which are arguments, into the constructor. And this is what allows us to write constructors and methods that work generically based on many different inputs. And this is parameter passing. Again, we're taking this argument and we're passing it to a particular parameter. And remember, when I said that they look like variable declarations because they are, this is what I mean. This is where we're declaring the variables, and then Java on our behalf is assigning values to those variables or initializing them using our arguments. Right? This is a really, really important concept. So I would recommend, if it didn't make sense the first time through, try watching again and then try playing around with this a little bit in hopes that it will. So the last step, once we've assigned our parameters, the values of the arguments we're passing in, we continue on through our code in this method or constructor, line by line, just the same way we did before. Anything we could do in the main method, like loops and if statements, or other method calls or other object constructions, that can all happen here as well. There's a pretty big difference between parameters and fields that I think is worth spending a moment to point out. A parameter's value is forgotten after a method call ends. And so are any variables that you declare within a method. These are called local variables. This is why we need fields. A field's value is remembered for as long as that object exists. So as long as you have a reference to that object, you can go and ask a field, hey, what's your x value? Hey, what Cartesian coordinate are you in? Hey, what's your quadrant? And it will remember the values that you stored in its fields. However, after a method call ends, it forgets what parameters were last assigned to it. And you can, the next time you call a method with parameters, you can provide different parameters, and the object is happy processing it. We assign values to fields so that we can later call methods on an object and use those methods or use those fields from the method calls. And so if you look back at the getQuadrant method of point, you'll notice that we can call getQuadrant on two different points, right? On point A, which was in quadrant 1, and point B, which was in quadrant 3, and get back two different results from the same method being called. And this is what's really, really quite beautiful and interesting about object-oriented programming. The exact same piece of code is running, yet depending on which object we call this method on, which object we call getQuadrant on, if we call a.getQuadrant, it's giving us back a different result than if we call b.getQuadrant. The code is exactly the same, but the values stored in their fields, their x, y fields, is different. And this is something that takes a little bit to click when you're learning object-oriented programming, but is a really, really big idea. So when does the program return back to the bookmark it left before it jumped? And there are two different kinds of rules here. The first is for constructors, when the closing curly brace of the constructor is reached, that's when it's done, and that's when we'll return back to where we came from. For methods, we'll return as soon as we reach a return statement. So consider the following code. Here, like we've been seeing, we're constructing a new point, and our point class is on the right, or at least a piece of it, the piece that contains the constructor. So 1, the point constructor is called, a bookmark is left at this point, we know we're going to come back here. 2, parameters are passed, and the CPU jumps into the constructor. So here we know that x and y parameters are assigned 1.0 and 2.0, and so 1.0 and 2.0 will be stored in the x and y fields. 3, we reach the end of the constructor, and this is where return happens from the constructor. We return back to the place where we came, back to where we left that bookmark. But now what happens is we've got an object here, and that object is assigned to the variable a. So if we wanted to think through this visually, just real quick, what happens is, one, when the new point keywords are encountered, what happens is Java sets up some space in memory and it allocates space for X and Y fields. We don't yet know what the values of these fields are, but we've set aside some space for them. Two, Java has copied in 1.0 to the X parameter and 2.0 to the Y parameter. It's assigned those values to these parameters. And then at this first line, we're saying assign 1.0 because that's X's value to the X field. So now X's field is 1.0, assign 2.0 to the Y field. And so now its fields are set up, they're initialized. That's the point of the constructor. We reach the end of the constructor and we jump back to where we came from. And so now, after this code has been evaluated, this is no longer new point 1.0, 2.0. It's actually this object down here. And so what we would say is after that line runs, A, the variable A, now refers to this particular object in memory. This particular object is a point, and its X field is 1.0 and its Y field is 2.0. And this is how we constructed it and set it up to be ready for use. Now let's consider a different method. Let's actually consider a method. Previously we looked at a constructor. So notice that we just called a constructor here, right? And we'd set up a point for 5.0 and 1.0. So I'm going to set up A as an object that has an X field of 5.0 and a Y field of 1.0, right? And so that just jumped through those steps we did on the previous slide. And now what's happening is we're reaching a call to a.maximum. And that whatever that returns to us is going to be assigned to the variable max, right? And so consider this maximum method, and its purpose is to return to us the greater field of X or Y. If X is greater, it should return X. If Y is greater, it should return Y. If they're equal, we don't really care. It can return either of them. And so my first question to you is, does this actually return the greater of the two? What happens when X is greater? And remember, the same rules for if then else apply. In order to answer that question, we actually need to talk a little bit more about the return statement, because there's a detail that's a very, very important detail. Actually, maybe it's so much of a detail that I wouldn't even call it a detail, but it's a rule that applies to the return statement. So the general form of a return statement is this. It's the return keyword followed by an expression. And that expression has to match the type of the method it's declared in. So for example, here we're saying the return type of this method maximum is a double, and here we're saying return statement X is a double field, so that's okay. Right? Next, we need to know, and this is what's important for understanding this particular method, is that every method must have at least one return statement. And as soon as that return statement is encountered, the method call is complete. So the very first time you run into a return statement in a method, your method is done. Its job is complete. It's going to stop everything it was doing previously. It's going to take whatever value its expression results in and return that to where it came from, and that method call is done. It's got no more work to do. All right? And this is super, super important to know, because this is true even if the return statement is inside of an if-then statement or a loop. All right? So let's go back and consider how this particular maximum method works and convince ourselves that it actually is indeed correct. So first, the maximum method is called on point A. We're going to leave a bookmark here that says, hey, we're coming back here. Don't worry. We'll be back. And we're going to come back with a double value because that's what you're asking for. And that's what this method is advertising it's going to return. Next, the CPU jumps into the maximum method. And remember, our variables for X and Y fields are 5.0 and 1.0. So these were what were stored in the field when we constructed this point. And so this is saying if X is greater than Y, so if 5.0 is greater than 1.0, which is true, we're going to enter the then block. And what do you know? We reach a return statement. Because that return statement is reached, we're going to take whatever this value is, so that's 5.0, and return it back to where we came from. So the last step here is we are going to evaluate a.maximum for this particular call to be 5.0, right? And 5.0 would then be assigned to max. And now this is super important to understand how this particular return statement works, right? So even though there wasn't an else here, and this return statement should have run after this then block, because we reached a return statement, the method ended, and we took the value that method or that return statement was trying to return, and we replaced that method call with it, right? And so as soon as you reach the very first return statement, when a method is running, you return at that point. Now we could consider a case where y was actually greater. So if this is false, we would skip over that return statement and we would return y. But because x was indeed greater than y, we returned x straight away and we never ran anything else down here. This has some important implications when we start dealing with loops as well. We'll see that in the next few slides. So a method call can only ever return once, and it can only return a single value. Because a method call is an expression, that means, sort of by definition, that a method call must evaluate to a single value. A method can't return multiple values. It can return an array, but that's sort of a different thing. That is still an array is still considered a single value. It's just one value that contains many. A method may contain many return statements, and if you looked at get quadrant, you would see that there's multiple get return statements within it in different branches of the if then else blocks. A method can return from within a loop, but what we'll see is if it does return from within a loop, it doesn't loop again. Like that method is done. As soon as that return statement is reached, even if there was more looping that should have been done otherwise, it's not going to happen. As soon as a return statement is reached, that method call is complete and the value is returned to the method caller. So let's take a look at how this comes to play in something a little bit more advanced. And let's take a look at the idea of a path. So a path is a series of points, and we'll model it as a field that can store an array of points. And what we want to be able to ask is two questions. Hey path, what is your largest y point, or what is the highest point on your path? So in this case, we know that the highest point is this one, right? It has the largest y value. And the next question that we want to be able to ask a path is, are all of the points in the same quadrant? So for example, are all of the points in this path in quadrant 1? That would be false. If you could imagine another path that looks something like this, and we asked, are all of the points in quadrant 3, we would expect that to return true because all of the points in that path are in quadrant 3. So how can we find the highest point in a path? We're looking for the largest y value. You've actually seen a simple example of this on a previous worksheet where there was a for loop which found the largest integer value in an array. We're going to do something similar, exact same idea, but here we're going to be looking at an array of points, and we're going to be looking at the points y values. For humans, this problem's easy, right? We just look at this and we see, oh yeah, there it is, no problem. Or we trace along and it's no problem. But for computers, when we have to specify this algorithmically, we can only compare two things at a time. And so we have to break down our problem to be very, very step-by-step. And we're going to move through each point, and we're going to try and remember the highest point that we've seen so far. And by the time we've looked at all points, if we've still remembered the single highest one we've seen, that's going to be our highest point. So let's look at the pseudocode for this. So we're going to start with the very first point, and we're going to label this point max, right? And then we're going to move to the next point. I'm going to call this next. So now that we're looking at the next point, we're going to ask, is the next point's y value greater than max's y value? Here the answer is no, they're the same, right? So then we reach step 3, and we're going to repeat step 2 for every point in the path. All right, so we got to move to the next point. So next is now going to be this particular point. And now we ask, is this particular point y, which is, this is at 1, 2, 3, 3, 2. So its y value is 2, and this is at 1, 1. Is the y value of 2 greater than 1? Yes. So if it's yes, what we're going to say is we're going to label this point as max. All right, so this is the new max point. All right, we're done with that. We need to keep going. Repeat step 2 for every point in this path. So we move on once more. We ask, is this point's y value greater than max's? The answer is no. We've now looked at every single point in our path, and max is the highest point in this path, so we're going to return it. This is the algorithm behind how we'll find the highest point in a series of points in our path. So before we jump into the actual code for this, I think it's worth spending just a minute to set up our demo code in Eclipse to be able to run this so that we can talk through it. So if you'll flip back over to Eclipse, and the two files that you're looking for are path and pathtest.java. So I'm going to open those up and get them side by side. So I would encourage you, maybe for this first example, to use those exact same points. So 1.0, 1.0, 2.0, 1.0, 3.0, 2.0, and 4.0, 1.0. So these are the exact same points we had in our in the slide just previously. So we have our first point at 1.1, 2.1, and then the point that was our maximum is going to be point C. And notice that what we're doing here is we're assigning these points to variables, and then we're making an array of points from them. So here's our array of points. And finally, we're constructing a new path using that array of points. And you'll notice that in our path class, you'll see that it has a field named points. It's an array of points. And we're using that same parameter sort of convention to say, if we give you an array of points, I want you to assign that to the field. So after we construct this path, it's got those points memorized as its sequence of points. And then we reach this getHighestPoint method. And so this is exactly what we'll see happens in the slide, and I'll talk through it in just a second. If you'd like, feel free to pause the video and try reading through it yourself. We'll see that this gets printed out when we call the highest down here. We call path.getHighestPoints, and that's going to try and find the point that is the highest in this path. So I'm going to run this and just see if we get what we expect, and then we'll talk through why we do in just a second. So here's 3.2 is what we expect to get out. And sure enough, the highest is 3.2. All right. So let's talk through this step by step. Remember, we've constructed a path and it has these 4 points in it. You could add more points if you'd like. First, what we're doing is we're saying that the very first point, we're going to label that max. And the way that we sort of make a label in programming is we just introduce a new variable and store that value in this variable. So here we're saying we're going to keep a reference to this first point in our points array and store that in the max variable. This is the local variable. And remember, local variables only stick around for as long as a method runs. All right? So max will be reinitialized and redeclared the next time around if this method's called again. Next, what we're going to do is you'll see we enter this for loop, and we're going to start at the very next point. So our first point was point 0 or index 0. Our second point is going to be at index 1. We're going to keep looping while I is less than the length of the points array. And so we enter our loop and we set up another label here, right? We say that the next point is going to refer to the point at index I, which is 1, the very next point. We didn't have to make this variable. This is just one that makes reading this code a little bit simpler, all right? So next we test, is the y value of this next point greater than the maximum point? If so, we're going to say that the maximum is assigned whatever this next point is that we're looking at. So if the point we're currently looking at is greater than, has a y value that's greater than every point we've seen before, we're going to store that in max, right? We're going to repeat this for every single point in our array, right? We're going to increment I by 1, and we're going to keep doing this while I is less than points.length. So this ensures that we're going to look at every single point in our points array. And once we've done that, just sort of by virtue of having looked at every point and having kept track of the largest y value we've seen along the way, we can return the largest point we found in our sequence of points. Right? So when we return max, the caller of this code will be returned a reference to the highest point in our path. So this is one example of how we can use a method to make it very easy to run multiple tests. We could have many paths in our program, and we could ask any of those paths without having to repeat any code, what is your highest point? In this next algorithm, which is just another method implemented on the path class, we're going to look at how do we detect whether a path is contained entirely within a specific quadrant. That's to say, let's say our path looks something like this. We could ask the path, hey, are you entirely in quadrant 1? And it would tell us true or false. In that case, it would be true. If our path looks something like this, it would never return true regardless of what quadrant we gave it, because it's in 2 quadrants at once. So this method is going to tell us, is every point in this path in a specific quadrant? So how do we know if a path is in quadrant 1? Well, all of its points must be in quadrant 1. So we're going to have to look at all of its points to know whether a path is entirely in a specific quadrant. How do we know if a path is not in quadrant 1? Any one of its single points not being in the quadrant 1 or the specific quadrant we're looking for means that this will return false, that this is not a true statement. It's not contained entirely within a single quadrant. So note that while we have to look at every single point in order to know that it is in fact within an entire, every point is within a specific quadrant, if any point we encounter while looking through a given path is not in the correct quadrant that we're looking for, then we know right away that all of it is not, and we actually don't need to do any more work. So how do we make this happen? How do we actually write this in such a way in Java such that we don't have to look at every single point once we've found one that doesn't match? Well, here's where we're going to use that property of the return statement, the fact that as soon as a return statement is reached, our job is done, right? Because what we're going to say is, all right, if we're looking at a node, at a point in our path and that doesn't match, we're going to return false immediately. We're not going to go look at the next one and the next one and the next one, right? So that's kind of jumping the gun. We still have a few things to talk through before we get to that point. But the key intuition here is that as soon as we find a point, we can return false, that if it's not in the right quadrant. Otherwise, once we've tested every single point and we know that they all are in the correct quadrant, that's when we can return true. So the pseudocode for this is given a specific quadrant. So in this case, we're going to say quadrant 1. All right, so this is the quadrant we're looking at. For every point in the path, and so whenever you have a problem where you see something like for each something and something else, you tend to know that we're going to need a loop, and we're going to loop through each point in that given array, right? And then what we're going to do is we're going to test. Whenever you see a test or something like that, or ask, you know that there's going to be an if statement involved. So we're going to say, is the points quadrant equal to the quadrant we're looking for, which was 1? No, stop and return false immediately. True, keep looking until we reach the end of the very last point, right? So we've got to check this point, then we've got to check this point, then we've got to check this point, then we've got to check this point. Once we're done checking all of our points, that's when we can return true and know that every point in this particular path was in the quadrant we were looking for. So we can take a look at this in code, right? And so we've got a solution here that I would encourage you to spend a minute to reason through and think through. And you'll notice that here we're testing this method using two different arguments. So in the main method, we're calling on this given path is in quadrant 1 and is in quadrant 2. And if you wanted, you could play around with the values of your points to convince yourself that these actually worked, and you could try putting each of these points in quadrant 2. Each of these points is currently in quadrant 1. They're all positive x and y values. So when we run this, we expect quadrant 1 to be true and quadrant 2 to be false. So spend a moment reasoning through this particular code. Go ahead and pause this, and then I'll talk through the steps and make sure that we're on the same page. All right. So when we get to this point, what's happening is, first, when we call this method, we're having to give an argument that corresponds to this parameter quadrant. So let's say we gave it 1. Remember, what happens when we pass an argument is we assign the argument to this parameter. So it's kind of like saying quadrant is assigned 1. All right. Then we're going to look at each point. And remember, the way that we do that, the way that we loop through every single point, is we start from 0 because that's the first index of our array. We're going to keep looping while I is less than the length of the array because we started counting from 0. We're going to count up by 1 each time. All right. And then what I'm going to do is say, make another just sort of nice variable to work with here. So we're making a variable within this loop called point and assigning it the value at the points index I. Again, we didn't have to actually do this. We could have just written points index I right here, but this is pretty nice to read because we're saying for each point in this points array, we've got this point variable, and we're asking, hey point, is your quadrant not equal to the quadrant we're looking for? In other words, hey point, are you not in the quadrant we're looking for? If so, if you are not in the quadrant we're looking for, then we know that it doesn't really matter what the rest of these points have to say. The rest of them might all be in that quadrant, but as soon as we've found one point that is not in the particular quadrant we're looking for, we can return false. And this is where that return rule comes in really useful and really handy, but it's also kind of confusing at first because we're used to thinking, oh, we've still got to finish this loop. And no. If we find a single point that is not in the same quadrant and we reach a return statement, we're returning false back to whoever called us. All right, we're not going to look at another point. We're not going to care what the I variable was or the point variable, anything like that. We are done with this method. We're returning false, right? And our work is done. We're not going to loop again. We stop right there, all right? But let's say that every point in this path was in this quadrant. Well, what happens is we never reach this return statement, right? Because every path, its quadrant is equal to the quadrant we're looking for. And so we're done looping, and that means if we've completed looping, what's going to happen is we're going to return true after we've looped through every point and tested every single point, because we now know that every point in this path was indeed in the quadrant we were looking for. I would encourage you to spend some time reasoning through this particular method. It'll help you with the current problem set in a number of places. The same pattern comes up in many places when you're trying to test a collection of things or a series of things to make sure they are all something or all not something, and to make sort of assertions about what are the contents of this particular array of values. So in this lecture, we looked at parameters versus arguments and how parameter passing works. And then we spent a little bit of time looking at the semantics of return statements. And the thing to remember with return statements is that as soon as a single return statement is reached within a method, that method is done running. It's game over for that method. We just take that value, which in this case would be false, and we give it straight back away. We don't keep looping. You don't go and evaluate any other code in the method. The method's job is done. In the next class, we'll look at how methods can be called on objects, or how objects can call methods on themselves, and continue looking at more object-oriented programming fundamentals.